Now, moving forward with some more key terms here, it's a lot of what this chapter is about, a lot of key foundational ideas. We're going to define a parameter. A parameter is a numerical measurement describing some characteristic of a population. Now, when we say numerical measurement, don't get tripped up on that. That sounds fancier than it is. It just means we did some math and got something, an average, a median. Um, it can be a lot of different things. It just means we did some calculation and we described a characteristic of a population with one number. Okay, so we say numerical measurement, we just mean we boiled all the data into one number, like an average. So again, if you want to think about it in a simple terms, you can think of it just like an average that comes from a population. Now, there are more things we can do than averages, and we will do more than that. Okay, but that's just kind of an easy example um, to get you going there. And again, it's on a population. So I have here in the parenthetical an example, the average SAT score of every TWU student. Why do I know that's a parameter? Because a parameter is a numerical measurement on a population. And the example is the average SAT score of every TWU student. So again, we will use that word every, the word all, and that idea of a population. All three of those interchangeable. Okay. And then we're going to contrast that with the definition of a statistic. Now notice this is the definition of a statistic, not statistics, right? The English language is kind of wonky like that sometimes. Statistics is a discipline. A statistic is a singular numerical measurement, just like a parameter is, but it describes a characteristic of a sample, not a population. Of course, then, caveat is you can have multiple statistics, and that's different than the discipline of statistics, but this is no different than, there and there, or two and two, right? And again, we can add an example to this. A statistic describes a characteristic of a sample. And so remember, numerical measurement, just think like an average. We'll talk more about different options later, but now just think like an average. So we boiled down the characteristic of this average SAT score, but if it's a statistic, that means it was a subset of TWU students. I'll say 500, doesn't really matter the number. It's the idea that it's a subset because a sample is a subset. And there are way more than 500 people at this university. Notice you do have the letter matchup thing, a little mnemonic device for you. Make sure you understand this idea that a parameter starts with letter P, goes with a population, starts with letter P, statistic letter S starts with letter S, and it goes with the sample starts with letter S. So a sample is a group of people, or a group of trees, or a group of computers, or a group of buildings, or a group of countries. It's things, right? And a statistic would be, tell me something that describes a characteristic of that, right? What's the height of the trees, or what's the IQ of the people, or what's the processing speed of the computer, some characteristic, but we're going to boil that down, not of all the 500 of them or something, but into one number, like an average or a median, right? That's a statistic as long as it's of a sample of, trees, computers, whatever. If you were able to get all of them, all the people, all the trees, all the computers, whatever, and we had a population, when we did that same numerical measurement, the processing speed, the height, whatever, and we found an average, then that's a parameter. Okay, so sample population is a who, and a parameter statistic is a what. It describes something, boils it down into one number for us. And so we'll have an example here. An elected official wants to know how well she will do in an upcoming election. She hires a consulting firm, polls a bunch of people, and the consulting firm finds 57% will vote for her, and it turns out that she wins with 60% of the vote. Identify the parameter in the statistic. Now, notice this problem does not ask you to identify the population in the sample. You can do that if you'd like. If you were to do that, the population would be all people who vote, or in this case voted, past tense, and the sample would be the 3,150 people who we polled. And that may be helpful for you in identifying the parameter in the statistic, because remember, the parameter and the statistics are just the numerical measurements that come from those populations or samples. Now, you may be asking yourself here, there's a lot of numbers, and this is where we have to try to understand what numbers are important and what numbers not. So this is just good reading, I don't want to say comprehension, because I know you can comprehend the words, but that sort of skill where how can we pull out the important piece of information? That it's a very important skill in this course. And so the 3,150 is a number that tells us how many people are in the sample, but the question doesn't ask us about that, so that number is not actually important. In this case, the parameter is going to be the 60% because that's the number that goes with the all the people who actually voted. And the statistic will be the 57% because that is the percentage of people who said they would vote for her. Notice that we did not actually use an average in this case. Remember, we kept talking about numerical measurement. Think of like an average or a median. A percentage would also be a numerical measurement, right? If I had 100 people and I polled them and I asked them a question and 37 said yes to whatever question I asked them, you said, oh, 37% of people said yes. That's a numerical measurement, right? It's a way that I took a whole bunch of people, a whole bunch of things, and I boiled it down to one number. So a percentage is another example of a numerical measurement. A couple more examples here. Determine whether the value is a parameter or a statistic. Again, we're just trying to figure out, is this numerical measurement coming from the all or coming from a subset? Following the 2006 national midterm election, 18% of the governors of the 50 United States were female. And so the 18% is the number in question, and that would be a parameter. Why would that be a parameter? Because it's a numerical measurement that comes from the all, because it comes from the 50 United States. That's all of them. There's only 50 states, at least as of this recording. Eventually, if this gets old enough, maybe, Puerto Rico becomes a state or DC becomes a state, but for now there are only 50. So because we have all of the states in the sample, or excuse me, in this data collection, that makes it a population. And so the numerical measurement is a parameter. In a national survey of high school students, 25% reported that someone had ordered, sold, or given them an illegal drug on school property. In this case, notice that for this to be a parameter, that means we would have had to have gotten communication from every high school student in the country. It's a national survey, so it's the entire U.S. high school students. So if this is a parameter, you're telling me that we talked to literally every high school student in the country. That seems pretty unlikely. Not impossible, but pretty unlikely. And so we're going to kind of make a reasonable assumption here that this survey only talk to 100 or 1,000 or maybe 10,000. It'd be a really big survey, but it didn't talk to all however many million high school students there are. And so because I'm going to make a pretty reasonable assumption, I think that this is a sample. We didn't get all the high school students. That would then make that 25% a statistic. And the last one, only 12 men have walked on the moon. The average age, remember we said numerical measurement could be an average. In this case, we do have an average. The average age of these men at the time of their moonwalk was 39 years, 11 months, 15 days. And then we have to ask ourselves, this average age, is that a numerical measurement that comes from a population or from a sample? Well, there have been 12 men who walked on the moon, and we have the average of those 12 men. That's all. That makes that a parameter. If the question said 12 men have walked on the moon, but the average age of 8 of them was given, then you would say that's a statistic, because we would have an average on a subset rather than the entire population. But because we are seeing the average age of these men, notice again, kind of have to learn how to read the question really well here. It's referring back to these 12, and that makes that a parameter. And what I hope you're seeing in some of these examples here is, if you didn't catch some of the way we read those problems and some of those inferences we made, go back through those a second time. That's going to be really crucial to your success in this course, being able to read the problems and understand what's happening. This is a math course, but there's not as much math as you might think in it. Notice here we're just about done here with the first lecture, and we haven't done any math. We won't do any math in the next lecture either. There's a lot of critical thinking, there's a lot of logic, there's a lot of how do we read and pull the right information, because there's a lot happening, a lot of new terms, kind of like a new language. And so use examples to understand as we move forward in this class. There's going to be some math, but it's not going to be a traditional math class. There's going to be a lot of situations where we have to understand exactly what we're reading in the problem. So if that felt a little bit weird, go back through those and try to see if you can pick up what I was talking about.